All right, now we're going to talk about making some decisions based on statistics. Now, one thing that you have to realize is that we're making decisions based on statistics can be very complicated, and one reason is because of improperly done statistics. So we're going to go over some definitions and look at a few things to make sure you understand when you can make decisions based on statistics and when you can't. Um, the methods of using statistics to draw conclusions about real world phenomena is called inferential statistics. And we are just barely going to touch this. So, so let's get started. All right, statistics are misused all the time. Remember, we talked about how you have to have a random sample and you have to have a sample of the proper size. If you don't have these things, then you're not going to have any statistics that are worth using for decisions. If someone tells you that Americans are going to vote for a certain person, but they've only looked at 100 people who all live in Philadelphia in a certain neighborhood, then that's not a random sample, and it's not a big enough sample to deal with the entire voting population of the United States of America. You need something random, which usually it's best to have a random number generator kind of computer thing pick people to do for that, or if you were interviewing people in the school, you could take the entire list of kids in school and you could draw names out of a hat, or you could decide that you're randomly going to pick every fifth person on the list or something like that. But you'd want to make sure you had a sample where you had a portion of every grade, and you'd have both males and females, and people who lived out in ranches and people who lived in town, and you'd want to have a whole random sample of the population. And for our school, we have a small enough school that you could probably pick 20 or 30 people and get a decent sample. You might want to go a little bigger than that, but for the population of the United States, for example, you'd want to pick a few thousand people, or you're not going to have much to go on. So when you're trying to do this, once you make sure you've got a random sample and it's a sample of proper size, you want to look for something called correlation. And what that does is it tells you how variables go together. So if you do a scatter plot of your data, let's say you do a scatter plot and you plot the data and it looks like this, and it's going up like this. This is called a positive correlation. And it would be a fairly strong positive correlation because it seems to be all going up. Now what's this then? If you can see all those dots. Hopefully you can. Now this one's a little bit more bunched all over the place, but it's still slightly going down. So this would be a weak negative correlation. There are other different positive and negative is not the only way you can do it. If you look on your calculator, you can do all kinds of regression lines. For example, you could have a data that plotted out like this, and that would be a very strong association. And it would be something that you would look at and say, well, I'm going to look at a quadratic for that, or maybe a quartic equation, and it would be a model that would fit it very well because it has such a strong association with between its variables. Now, if you have something that is scattered all over the place, then you don't really have any kind of correlation, and you're not going to be able to come up with anything to bring those two together. And so this kind of data wouldn't be useful in making any kind of decisions at all. So the biggest thing you need to look at is making sure you have a random sample and making sure that it's a big enough sample, and then seeing if there's actually some correlation to those two. Now, the other thing that you have to look at is see if there's any kind of bias. For example, if you have a local talk show host that wants to get the opinion of the city about tax increases, so listeners can call in and they're giving their opinion. Well, listeners calling in to some kind of talk show host, that's going to be a little bit of bias because people are volunteering for the sample, and most people who volunteer are going to be ones who feel strongly about it one way or the other. So you have to watch out for bias and see what happens with that. Whether it, like, if you ask questions about abortion opinions and you went into a church to take examples, then obviously people there are going to be strongly biased. There's not going to be any kind of random sample to tell you what the whole population of the United States feels about that, right or wrong. That's just the statistical way it's going to work out. It also helps if you have something called a control when you're asking questions or you're doing an experiment. When you do a lab, you have a control to make sure that you have kind of a baseline for your decision, a baseline for what's happening. Then that will help. Sometimes if people are giving, like they're sampling water and they want to see which kind of water, they'll use just tap water instead of having all different kinds of bottled water. They'll have one that's a tap water so that it's kind of a control. And it helps if you have a blinded experiment where, like, if the water, you wouldn't leave the labels on the bottle. You wouldn't even leave them in their same kind of bottle. You would have everything in the same cup so that you would have you wouldn't know, because then you're going to have some bias. If you look at it and you say, okay, well, that's a Dasani bottle, I know that, and that's the one I like, then you're going to say that's the one you like, whether it really is the best one or not. So you have to look at all kinds of things when you're doing experiments for statistics and making decisions based on those statistics. So look at the experiment. Remember, we talked about it had to be random and you had to have a good sample size. You need to check and make sure you don't have any bias in your sample or in your questions. If your questions are leading questions and they kind of infer a proper answer, then that's a biased question and it would not be valid for a statistical sample. If you're doing experiments to gather statistics, you got to make sure you've got some kind of control so you have a baseline, and you want to make sure that you have a blind experiment or even a double blind where the person asking the question or the person conducting the experiment doesn't know what's going on, which one is which, so that you don't inadvertently point someone in one direction or the other. Once you have all the sample, then if this is all good, then you can make some decisions based on your statistics if there's a good, strong correlation when you graph your statistics. If you graph your statistics and they look like this, then you know there's a good, strong correlation because it's all the data points are flowing in one direction and flowing with one thing where you could put an equation to that. So you would be able to infer what would happen in other places. For example, if you're looking at stopping distances when you brake in your car, time, your speed versus distance that it takes to stop from the time you hit the brakes, there's a very strong correlation between speed and stopping distance. That's why we always tell you to allow plenty of space, especially the faster you're going. But if you have, and so you could infer how long it would take you to stop if you were given a certain speed based on the data that you had, because you could fit a good, it has a good strong correlation, and it could, you could see what was going from that. But if you had data that's all over the place, then these variables have nothing to do with each other. Like, for example, if you were looking at heart disease in rapid, and or where, based on where people live or something like that, well, that really wouldn't correlate too much. There are lots of other things that deal with heart disease, diet and exercise and family history and all that kind of stuff. But where you live isn't necessarily going to affect your level of likelihood of getting heart disease. So that wouldn't be a very strong correlation, and it wouldn't be something that you would be able to make decisions on. So think about this and think about good experiments and what makes a good statistical experiment, so you can decide if you can really use those statistics that you found in the paper on your latest sports team or whatever, and make decisions about them.